an inverse matrix is one that you multiply by another matrix. These matrices are actually inverses. This matrix, this is the inverse because when you multiply them together, you get the identity. Just as if you multiply 5 by 1/5, you get 1. 1/5 is the inverse of 5. And 5 is also the inverse of 1/5 while we're at it. So these matrices are actually inverses. But this is a matrix we started with, so we'll call this the matrix and we'll call this its inverse. Inverses multiplied together give you the identity. Okay, now I'm going to talk about this. We talked about this first, but I'm going to talk about this. If you have numbers, you know, this is just an algebraic equation. These are just numbers. They're not matrices or vectors or anything. A times x equals b. How do you solve that? Well, you'd probably say, well, divide both sides by a. So x is going to be b divided by a. That's great. We want to make an analogy with matrices, and there's no such thing as division by a matrix, though. Okay, you can't divide by a matrix. But as you see, you can multiply by an inverse. So to solve this, I'm going to write, instead of ax equals b, divide both sides by a and so forth. I can equally well solve it by saying a inverse times ax equals a inverse times b. A inverse being the multiplicative inverse of a. So if a is 5, a inverse would be 1/5. Now, the multiplicative inverse is also the reciprocal, but we call it the multiplicative inverse because you can't do a reciprocal of a matrix either. So using the terminology we use with matrices, we solve this equation by multiplying both sides by the inverse of A. Well, now we have a matrix equation, AX equals B. This is this equation, this equation, and I think I might have pointed to it wrong before. This is this, where A is this matrix, the 2, 1, -4, 3 matrix. X is the column vector xy, and that takes a little bit of explanation. This x is not the same as this x because this x has an arrow over it. So this x is a vector, column vector, consisting of the numbers x and y, or the variables x and y. Okay, so this x is not this x. Now, when we go a little further, we're not going to be using x and y. We'll use like x1 and x2, so that both of these numbers are kind of related to x. Okay, and you'll see that when we get to it. It's a little confusing here, but don't worry too much about it because we're going to change it. X is this vector, and b is this. So, you know, where do these come from? Well, they come from this equation. Okay, A is this, so there it is. A is here. X is this column. Okay, the X with the arrow over it is this column, so there it is. And B is this column vector, which is here. Okay, so make sure you see this as AX equals B, where the X and the B both have arrows over the top of them to indicate that they're not single numbers. They don't stand for single numbers, they stand for vectors, for column vectors, for columns. Okay, so the solution to this is really quite simple. We simply multiply both sides here by A inverse. Okay, if this is the matrix A, then A inverse is going to be this matrix. Since this matrix, this is the A matrix, multiplied by this you get the identity. So this is the inverse of this thing, which is our A matrix. Okay, so we're going to have our inverse matrix when we get around to using it. But we do A inverse times AX equals A inverse times B. We will have multiplied both sides of this equation by A inverse. Okay? Well, what's A inverse times A? It's the identity matrix. That's what we mean by inverse. Okay? And the identity matrix is a matrix that doesn't change what it's multiplied by. So I times X is just X. Now on the right hand side you have A inverse B here, here, and here. Okay? But now we can calculate x, this x vector, which will consist of solution for x and y. Okay, so we have x equals A inverse B, so we take A inverse, and I messed it up. I wrote down 3 and 2, I think, or 2 and 3 instead of 3 and 2 when I did this. Clerical difficulties, keep an eye on me, okay? But I multiply this by the B vector 5, 2, and you can verify that this is what we get. It's a very simple matrix multiplication. Fractions all have the same denominator, so it's real easy to add them. And we get that result. Oh shucks, I went over time. I knew it was happening. Okay, well, since I'm over time, I'm going to have to split this video, which takes a while. And that's unfortunate, but we'll have to do it. Okay. Now, what's the significance of this? Well, I didn't actually write it out in class, but this is our x vector. So I could write out xy, which is our x vector, equals this, which tells us that x is 17/10 and y is 16/10. Now we come over to here. And actually I'm going to be able to split that video. I just realized I found my device. It's right where it was. Okay. So we plug this value of x in here, 17/10. Multiply it by 2, we get 34/10. Y is 16/10. 34/10. 34 and 16 is 50, so we get 50/10, which is 5. Then -4 times 17 is -68. 3 times 16 is 48. -68 and 48 is -20, so we get -20/10, which is -2. Bingo, it worked. Okay, now there's a whole lot to this scheme. If you understand this scheme, then you pretty much have the whole picture for solving systems of equations using matrices. You can do it by row reduction. You can do it by writing a matrix equation and using the inverse matrix. The only trick is finding the inverse matrix. Now, I just showed you how to find the inverse matrix, and there's actually a little easier way. We define what's called a determinant. So you don't necessarily have to remember what I just told you, but it doesn't hurt to remember it, because we're going to use what I told you to define the determinant. Okay, I think that's what I'm going to do when I define the determinant, if I remember. I've never done it that way. I always like to do things in a unique way. Okay, so but yeah, I kind of forget where I was going now since I digressed. Oh yeah. So I was talking about the inverse matrix. So it's easy to get the inverse matrix for a 2x2 matrix. I mentioned if you got a 3x3 matrix, it's a little more complicated, a little more work. It's manageable. Doesn't take that long. If you get the bigger matrices, and if they don't kind of simplify before you have to start really doing stuff, you really just basically go to computer software. And your calculators will do matrices, they'll invert matrices. But you need to know the process, because sometimes you have to do things symbolically, improve things symbolically, and establish your methods symbolically, and that's one of the things you learn in this course, how to prove things, how to check out your methods. Okay, so that's pretty much it. Okay, so there you have it. This is one video, but it will be split into two, about 10 minutes each.